Okay, so just to address a few of those questions, I'm hoping I get all of them. So the first one here, this one was a mistake, and it's something I overlooked, and that is what we talked about last time was finding this distance and multiplying it by 2, which makes intuitive sense. But if I were to draw that on here, what did we find? Well, we ended up finding this distance, right? Now, notice it's at an angle, and then this distance. So the answer you got of 34 something is actually the length of that blue line. So if you think about folding this, that is the distance. That's not the red distance, is it? So to find that red distance, you still need to use the number that you got of 17 point something. Now, if you look carefully, if I split this red line exactly in half, you will have a right angled triangle in here. Okay? With the hypotenuse being the length of the blue line you found earlier. Okay? Which means that this length would be 17.32 or 34, whatever you said it was. In fact, I still have it on. 17.32. And this pink line, because it's exactly halfway through the square that's formed in the middle. Now we know the square is going to be also 20 by 20 by 20 by 20, right? Which means this would be 10. So now using Pythagoras, so 17.3 squared minus 10 squared, and the square root of that, you would get this length. And then whatever that length is, multiply that by 2. And you would get the same answer the textbook gave you. Okay? So just a minor oversight. And I think you had another question down here, or was it 7.3? Yeah, okay. So this question here, I can't remember what your question was regarding this one, but this one is talking about 2 koalas sitting on top of 2 trees, which are located 10 meters apart. Rocco's tree is exactly half as tall as Biff's. Now the important thing there to realize is because it's half as tall, then this distance is the same as this distance. Okay? And I also know that's 10. So by doing that, that means I know that that is 90 degrees, and I know that that will be 35, and I know that that will also be 35. And then from that, what do we need to find? How high off the ground is each koala? So in this case, if you just use SOHCAHTOA and this with 35 degrees, 10, and this height, that would be the height of the first koala, and then times 2 would be the height of the second one. And I think you had a couple down here. 28 and 30, I think you said. 28. Okay. An airplane is cruising at an altitude of, so you got an airplane. That's an airplane cruising at an altitude of, this is 10,000 meters. It is flying in a straight line away from Chandra. So Chandra is somewhere here, and the plane's going in this way. So it ends up here somewhere. Who is standing on the ground? If she sees the angle of elevation of the airplane change from 70 to 33, which means this is where she saw the airplane originally, okay, and this was 77, and then later on, in a minute exactly, it changes to 33. It's asking for its speed. So, our job is then to find out what this distance is. Okay? Because if we can find out this distance, how far did it travel, then let's say he traveled, I'm going to make a number up, let's say 5,000 meters, then we know she traveled 5,000 meters in a minute. And all you have to do is change that meters per minute to kilometers per hour and convert it. Okay? Now, in order to find the distance, however, we would need to find, so let me see here. So this is going to be tricky. There's 2 triangles. So the first one is this triangle here, which would be, you know that this is 33, which means this angle in here would be 90 minus 33. And you know that this distance is 10,000 meters, right? So if you know this is 10,000 meters, you know that this in here would be 57. Then you use SOHCAHTOA to find this length. let's call it x. Or distance, sorry. Once you find that distance, then you can look at the smaller triangle. And again, you know that this height is 10,000. And you know that this angle here would be 90 minus 77, so 13. So this angle would be 13 degrees. So 13 degrees and 10,000, you can find this length or distance of y. And then x minus y, x is the blue, minus y the red, you would get this distance, whatever that distance is. And then once you get that distance, that will equal to distance. And then to find the cruising speed, it would be distance in meters per 1 minute. So that's meters per minute, and then you just have to convert that to kilometers per hour. Okay. So this question number 30 has a similar idea. I'm going to draw the picture over here, but we have a building. The angle of elevation to the building is 30 degrees. Okay. Now, from a point 20 meters directly toward the building, which means I'm going to move 20 meters forward, okay, the angle of elevation changes to 40, which means this is now 40 degrees. Okay, so our job then is to find the height of the building. So what I'm going to do is try to write out a statement for that. So I don't know this red distance, do I? I'm going to call that x. I don't know this distance. So using SOHCAHTOA, I can use sine of, no, not sine, sorry, tan of 30 equals opposite, which is the height, divided by adjacent. Now adjacent would be 20 plus x. Now there's an issue, isn't there? I see two variables. So I look at this and think, is there a way I can get rid of the variable? There is, because if I look at the red triangle, I can say, okay, tan of 40 is equal to opposite, which is also my height, divided by adjacent, which is x. Now I have two formulas, two equations. So all I need to do is substitute this into that. So the easy way here is to notice that x times tan of 40 is equal to h. Now, so thinking about substitution, that means in this first equation I now have tan 30 is equal to, instead of h now, I'm going to have x tan 40 divided by 20 plus x. Now in this case, all I need to do is solve for x, okay, which will give me this little distance here. Once I have that distance, I can substitute it in here and solve for h. Okay. Hopefully I answered any of those all those questions. If not, again, just shoot me another email, okay? Alright, take care. Bye.